Hello, welcome to Pre-Cal Lecture 1.6. We're going to be talking about simplifying radicals and rationalizing. You'll be taking these notes on your own paper. So we'll start with section 1.6.1 and we'll call this simplifying radicals. Okay, our first example is let's simplify 121 over 100 to the minus 3/2 power. So I'll show you a little trick here. If you have something raised to a negative power, you can flip the fraction inside and make the exponent positive, and it's the exact equivalent value. So we can flip the inside, put it as 100 over 121, and raise that. Now you don't flip the fraction, you just change the sign. You don't flip the exponent fraction, just change the sign. So that's to the 3/2 power. Now that is the same as the square root of 100, because 2 is on the bottom, so the square root of 100 over 121 all cubed. Okay, so what is the square root of 100? That's 10. What's the square root of 121? That's 11, and then that would be cubed. So you could then you'll use your calculator if you need to. Hopefully you know that 10 cubed is 1,000, and then 11 cubed, you probably don't have that memorized, but it's 1331. So you can just raise that 11 to the third power in your calculator, and you're good to go. All right, next example, let's simplify the cube root of 64 times 3 to the 6th power times 5 to the 3rd power. I'm going to rewrite this. Instead of a cube root, I'm going to rewrite this to a fractional exponent. We're going to rewrite all of that to the 1/3 power. So that'd be 64 times 3 to the 6th times 5 to the 3rd power, all of that raised to the 1/3 power. Okay, so now we can take each individual component and raise it to the 1/3 power. So that's 64 to the 1/3 times 3 to the 6th to the 1/3, and then times 5 cubed to the 1/3. And then you're going to 64 to the 1/3. If you don't have that memorized, you can put it in your calculator, but that's 4. And then when you raise an exponent to another exponent, you multiply. So 6 times 1/3 would be 2. So that's times 3 squared. And then 3 times a third is 1. So then times 5. So that's going to be 4 times 9 times 5. And that would be 180. All right, again, of course, you could use your calculator. But on a test, on your homework, I want to see all this work. So don't just put all this in your calculator in one pop. Show me the work. Okay, next example. Let's simplify. So we have negative 8 over 343 to the 1/3 power. So our exponent's already positive, so we don't want to flip and then make the exponent negative. But this is the same as negative 8. So we can separate the numerator and the denominator. So negative 8 to the 1/3 over 343 to the 1/3. Okay, so negative 8 to the 1/3, what number times itself 3 times would give you negative 8? What times what would give you negative 8? That's what this is saying. Well, that would be negative 2. Now you can make sure, you can check it, double check it by putting it in your calculator. You may not know what 343 to the 1/3 is, the cube root of 343, but it's actually a whole number, and it is 7. So just practicing putting this in your calculator. All right, so that's going to be negative 8 raised to the 1/3 power. Okay, that gives you the negative 2 answer, and then 343 raised to the 1/3 power. Now, if you have the older TI-84 that doesn't do this automatic exponent when you hit the caret symbol, it doesn't raise it up, you may have to put these fractions in parentheses. So if you do have an older one, just know you might have to use parentheses. So that's 7 there. So you can use your calculator to double check, but it is nice to have some of these common numbers memorized. All right, pause the video if you need to while I am erasing, or fast forward if you're all caught up. And we'll go to section 1.6.2. And we're going to call this simplifying radical expressions. With variables. Okay, so instead of just raw numbers, this time we're going to have some variables that we're going to simplify. So our first example, we want to simplify the square root of 25 x to the 6th y times y to the 5th. So I like to write this as, instead of a square root, a fractional exponent. So what fractional exponent would that be? All right, it'd be to the 1/2 power. Okay, so now we can take each of these, 25, and raise it to the 1/2 power. 25 each component times x to the 6th to the 1/2 power times y to the 5th to the 1/2 power. 25, that's the square root of 25. It's just saying what's the square root of 25. You know that's 5. And then x to the 6th raised to the 1/2. 6 times 1/2 is 3, so that's x cubed. And then y to the 5th raised to the 1/2. 5 times 1/2 would be 5 over 2. I like to use the old term and call it 5/2. So y to the 5/2. Now, some teachers would make you change that 5/2 into a y squared times root y. I'm not going to make you do that in this class, because in calculus we prefer the fractional exponents, and since this is pre-calculus, in algebra 2 or algebra 1 you might have had to do that. In pre-calculus we're training you for calculus, so I want you to leave that to the 5/2 power and don't worry about putting it in radical form. All right, next example. Okay, this is pretty nasty looking. So we have the 4th root of 32 r to the 6th times s times the 4th root of 2r s to the 4th. So both of those are the 4th root over the 4th root of 4r cubed s squared. All right, so that just looks terrible to have to, and our instructions would be to simplify this. Looks terrible. But since it's all to the 4th root, we can rewrite this entire thing raised to the fourth root. So I'm just going to get rid of the radicals, and we'd have 32 r to the sixth times s times 2 r s to the fourth. We're going to be able to combine a lot of that over 4r cubed s, all raised to the 1/4 power. Now what you want to do is simplify all of this inside the parentheses before we raise it to the 1/4 power. So 32 times 2 is 64, right? So we'd have, on top you would have 64. And then r to the 6th times r, you would add the exponent, so that would be r to the 7th. And then s times s to the 4th, add the exponents, that's going to be s to the 5th. Remember, when we're multiplying the same base, we add exponents. When we're raising a power to a power, we multiply. That's probably the most common mistake, is just forgetting to do it that way. And then over 4r cubed s. And we're raising that to the 1/4 power. Now it's pretty easy to simplify. 64 over 4 is 16. Now we're going to put everything on one line here. 16. R to the 7th over r cubed, 7 minus 3, that leaves r to the 4th. And then s to the 5th over s, 5 minus 1 would be s to the 4th, all raised to the 1/4 power. And now we can do our final raising each individual component to the 1/4 power. So that's 16 to the 1/4 would be, what's the fourth root of 16? Well, it's 2. 2 times 2 times 2 times 2 would give you 16. R to the 4th to the 1/4 power. 4 times the 4th is 1, so that just leaves r. And then s, by the way, this was s squared. I'm so sorry. So this would be s cubed here. So s to the, all right, so s squared. I dropped the s squared way up here. So I apologize for that. Glad I caught it before I erased it. So s squared there, s squared there. All right, so 5 minus 2 would be s cubed. And then 3 times the 4th would be s to the 3/4. And I won't, that's really all you can do. I won't make you write the s in radical terms. Just leave it like that. Again, sorry I dropped that squared right there, but we got it fixed. Okay, that looked, so 2rs to the 3/4 is just a much simpler way of writing this nasty thing. Awesome. All right. This is kind of fun. I hope you think so. You may not. All right, we're still on 1.6.2, which was simplifying radicals with variables. So let's do another example. Let's simplify the square root of 20 u to the 4th v squared w to the 5th all over, so all of this is under the same radical. Give myself a little more room. All over 80 u to the 6th v cubed w to the 3rd power. Okay, before we go ahead and raise all this to the 1/2 power and everything, let's simplify it underneath the radical first. Okay, so 20 over 80, that's the same as 1/4. So what we've got left with the constants is we would have a 4 on bottom. It's 20 over 80, so that'd be a 4. U to the 4th over u to the 6th. Well, the bottom wins, so what's left is u squared on the bottom, right? 6 minus 4 is 2, so that goes to 2. All right, v cubed, v squared, the bottom wins by 1, so it's just going to be v. All right, so that would cancel out, and we're down to 1. And then w to the 5th over w to the 3rd, 5 minus 3 is 2, so you're left with w squared on top. Okay, so now what I'm going to do is raise all that to the 1/2 power. So w squared over 4 u squared v, all raised to the 1/2 power. So w squared to the 1/2, 2 to the 1/2, 2 times 1/2 is 1. So all that's left on top is a w. 4 to the 1/2, that's the square root of 4, that's just 2. U squared to the 1/2, 2 times 1/2 is 1, so you're just left with a u. And then v to the 1/2. So you can leave it as v to the 1/2, or you can write square root of v if you want. I'm going to teach you in just a second how to get rid of the radicals on the bottom. So, but for now, you can just leave it like that. Okay, last one in this section. We want to simplify. The 4th root of 81x to the 4th, y to the minus 12th, z to the 5th. So I'm going to rewrite all this and raise it to the 1/4 power. So we got 81 x to the 4th, y to the minus 12, z to the 5th, raised to the 1/4 power. Now I'm not going to move that y to the minus 12 down yet. We will eventually do that. Okay, so 81 to the 1/4. If you don't know what that is, just put it in your calculator and see what it is, but it's 3. 3 times 3 times 3 times 3 would give you 81. So we have a 3. X to the 4th to the 1/4. 4 times the 4th is 1, so we just are left with x. Y to the minus 12 to the 1/4. So minus 12 times 1/4 would be y to the negative 3. And then z to the 5th raised to the 1/4. 5 times the 4th is 5 over 4. So z to the 5/4. And all you've got to do now is move that y to the negative 3 downstairs. So we would have 3x z to the 5/4 divided by y cubed. All right, and that is good enough for me. So I want you to asterisk the rules I want you to follow. No negative exponents in your final answer. You can have negatives along the way, but I want you to remove them before you circle the final answer. And however, this isn't true of all math teachers, but it is of me in this class. Fractional exponents are okay. Okay, so that is going to save you some time. Those are the 2 rules I want you to follow on the homework and on the test. Okay, our last section for today's lecture. And today's lecture is probably a little longer than the average pre-cal lecture, which is pretty short. I'm going to go to the cloth here. Okay. It's called rationalizing denominators. Now, hopefully you did this in Algebra 2 or Algebra 1 even. So I've got a little bit of notes that I want you to write down, a couple of bullet points. It is bad form to have a radical in the denominator. Now, who decided that? I don't know. I don't see anything wrong with it, but mathematicians who may teach you in the future think it's bad form. So we can remove the radical in the denominator by multiplying the fraction by a clever version of 1. All right, a clever version of 1. A lot of math is just clever versions of 1s and 0s. Okay, so let me show you what I'm talking about by a couple of simple examples, and then we'll raise the bar on the example. So our first one, let's say we have 5 over the square root of 3. And I want to get rid of the square root of 3 on the bottom. Now I'm gonna shorten, instead of saying the square root of, I'm just going to say root from now on. So we could multiply this fraction by a clever version of 1. And that clever version would be root 3 over root 3. Okay, root 3 over root 3, that's just 1. So when you multiply it by 5 over root 3, it's going to give you the same answer, just you're going to get rid of the radical on the bottom. So this is going to be 5 times root 3, and root 3 times root 3, the radical lifts, and you just have 3. Okay, so that is the rationalized version of 5 over root 3. They're the exact same number. If you put them in your calculator and get the decimal version, it would be the exact same number, but this is considered better form. Should it be considered better form? In my opinion, no. I'm an engineer, not a mathematician, so I would just leave it like this. However, I have to teach you this. All right, next example. Let's say we have 2 over the square root of 2. What clever version of 1 would you use to get rid of the root 2 on the bottom based on what we just did? Well, hopefully you can guess that real quick. That'd be root 2 over root 2. So this would be 2 times root 2. Of course, you're multiplying here. And root 2 times root 2, the radical lifts, and you just have 2. This one even has a further simplification, though. The 2's cancel. So this simplifies all the way down to root 2. Pretty cool. Okay, let's do a couple of more challenging examples and introduce a new term. Hopefully it's not actually new to you, but it's called the conjugate. So do you remember in any of your other math classes working with the conjugate? If you did, it was probably Algebra 1 or Algebra 2. So we're still in 1.6.3. And let's try this example. Let's say we want to simplify. Okay, so the instruction would be to simplify 3 over the square root of 2 plus 1. Now, what could be a clever version of 1 that might cause this radical to go away? Well, let's try something. How about what we did on the last example was we just took the denominator and put it over itself and multiplied. So let's try that again. How about root 2 plus 1 over root 2 plus 1? This is just a good guess, right? Okay, so let's multiply that out. We'd have 3 times the square root of 2 plus 1 on top. And on bottom, we have to FOIL. First, outside, inside, last. I hope you remember that. So first, root 2 times root 2 would be 2. The outside, root 2 times 1, so that would be plus root 2. Inside, 1 times root 2, so plus root 2. And then the outside, plus 1. Did that get rid of the radical in the denominator? Nope, that didn't work. So didn't work. All right, let me try a different marker here. This one is getting a little too thick. All right, let's try if, just a little bit bullet point here. If we multiply the denominator, well, let me see. Multiply by, I'm going to rewrite this sentence, by the conjugate of the denominator, so it's the conjugate divided by the conjugate, the exact same thing, we can remove the radical. So conjugate. So the conjugate of this example, root 2 plus 1, you change the sign. Okay, so let's redo this example. Let's say we have 3 over the square root of 2 plus 1. The conjugate would be the square root of 2 minus 1. So we change that sign, whatever it is in the center. If it were a minus, we would change it to a plus. But we have to multiply it by 1, so it's the square root of 2 minus 1 over the square root of 2 minus 1. So that's going to be 3 times the square root of 2 minus 1. And on the bottom, we FOIL again. Okay, we're going to FOIL this. So square root of 2 times the square root of 2, that's the first, is just 2. The outside would be square root of 2 times negative 1, so that's minus the square root of 2. The inside is 1 times the square root of 2, so that'd be plus the square root of 2. And then the last would be 1 times negative 1, so minus 1. Well, that's really useful because minus root 2 plus root 2, those cancel. They cancel out, and you're just left with 2 minus 1. So you'd have 3 times the square root of 2 minus 1 over 2 minus 1, which is just 1. So you don't even have to write the denominator. That's 3 times the square root of 2 minus 1. All right. Oops, dadgummit. I made a mistake. Hopefully you caught this. That'd be minus 3 on top. Because you have 3 times square root of 2 and then 3 times negative 1. Well, no, I had it right. I had it right. You can leave it like this. My bad. I hope you didn't erase. You can leave it like this. I did, but if we were to distribute that 3, it'd be 3 times the square root of 2 minus 3. But I'm fine if you leave it like that. To me, that's probably, either way is fine. I don't really care. Okay, so when I eyeballed my answer there, I saw a 3 in there. Okay, let's do a couple of more, so you really get the hang of this. We're still in section 1.6.3. Again, most pre-cal lectures aren't this long, but I want you to have a lot of good examples for this homework. case you've forgotten how to do this or never did it, let's simplify 1 plus the square root of 3 over 1 minus the square root of 3. So your instruction might be to just simplify. It might say rationalize. Okay, what's the conjugate of the denominator? Well, you change the sign there, so it'd be 1 plus the square root of 3. Well, we have to multiply it by a clever version of 1, so we have to put it on the bottom, the exact same thing. Now we FOIL the top. That's going to be 1, and then root 3 times 1, and then another root 3 times 1, so plus root 3 plus root 3. The root 3 times 3, the radical lifts, so that's 3. And then on bottom, the center terms cancel. So you have 1 times 1 for the, and then you have minus root 3 plus root 3. So minus root 3, I'll write it this time, but probably not anymore. Minus root 3 plus root 3. Those two cancel. That was the whole point. And then minus root 3 times root 3 would be minus 3. Okay, so we know those two terms cancel. And on top, I got 1 plus 3, so that's 4. And then I've got a root 3 plus a root 3. That'd be plus 2 times root 3. There's 2 of them. And then over 1 minus 3. So that's going to be 4 plus 2 root 3 over negative 2. Now, in this case, these two numbers are wholly divisible by negative 2. So we can take this one more step. Negative 2 goes into 4 negative 2 times. Negative 2 goes into 2 negative 1 times. So minus root 3. So in order to get full complete credit, I'd like to see negative 2 minus root 3, or you might have done it in such a way that it's negative root 3 minus 2. Those are the exact same answers. Okay? And final example, we want to rationalize x over root x minus 2. So what's the conjugate? It's root x plus 2. So we're going to multiply those out. So we'd have x, and I would say in the beginning, don't distribute that x yet. So just leave it because something may cancel out. And then we're going to FOIL the bottom. Root x times root x is x. And then you'd have 2 root x minus 2 root x. Those two cancel. So I wrote it out this time, but you can just kind of do it in your head. And then minus 4. And you really can't do any more simplification with that. This is the answer. You cannot cancel out those x's because this x is attached to a negative 4. So it does not equal, you cannot, so this is one of the most common mistakes I see. If you have x times root x plus 2 over x minus 4, a lot of students want to do that. And that is a big no-no. Don't do that. That x on bottom is attached to a negative 4. If it were just x, if it weren't x minus 4, if it were just x, then the two x's would cancel. Okay? So this is the final answer. You can't cancel that x. Okay. The homework is worksheet 1.6. So that's got 15 problems on it like that. Okay, so hopefully you can fit them all on there, but if you need to use your own paper, go ahead and do that. Just I made these sheets a long time ago before Microsoft Word had the ability to do these radicals. So just to make sure that you can read this, Number 9 is the fourth root. I know it's tiny. Number 10 is the third root. And then everything else is just a square root. I think you can read everything else okay. All right. Well, I hope that lecture helped you out, and I will talk to you on the next one.